squaring and converting to quadratic type. So we're knee-deep in solving trig equations that involve quadratics. And we're given cosine x plus 1 equals sine x. And this is a situation in which you must square each side of the equation to obtain a quadratic. Because this procedure can introduce extraneous solutions. Extraneous solutions are solutions that are solutions to the squared equation, but not to the original equation. Anytime you raise both sides of the equation to a power, you should check to see that all the solutions that you get are actually solutions to the original equation to see if they are valid or extraneous. So we're given this, and I want to write this all in terms of cosine or all in terms of sine. So what I'll do, because I really don't have any other options, the link between sine and cosine, remember, is sine squared x plus cosine squared x equals 1. So if I square both sides, I'm going to have cosine x plus 1 times cosine x plus 1 equals sine squared x. Now I can FOIL this to get cosine squared x plus, I'll have cosine x plus cosine x is 2 cosine x plus 1 equals sine squared x. Now the question becomes, do I want to write this in terms of cosines or in terms of sine? Notice, because I have 2 cosines over here and only 1 sine over here, I can make the substitution. Cosine squared x plus 2 cosine x plus 1. I know that sine squared x is equal to 1 minus cosine squared x. And so, now I can start to simplify. Plus 1 and plus 1, if I subtract 1 from each side, those will cancel. If I add cosine squared x to both sides, I'm going to be left with 2 cosine squared x plus 2 cosine x equals 0. Remember, I want to set up that zero product property. So in order to do that, I'm going to factor, because I want something times something else equals 0. What's common to both? 2 cosine x. And what's left over if I take out 2 cosine x? Well, I'm left with cosine x plus 1. And now that I've got this times that equals 0, I can say 2 cosine x equals 0 and cosine x plus 1 equals 0. So cosine x equals -1. If I divide both sides by 2, I get cosine x equals 0. All right, so these are pretty easy, right? Where is cosine equal to -1? At what angle in this restricted domain? Because we're only allowed 1 unit circle from 0 to 2 pi. Include the 0, don't include the 2 pi. Well, if the angle is pi, we're over here at -1, 0. So if the angle is pi, our cosine, or on the unit circle, that's the x, is -1. So x equals pi. We're solving for the angle. Remember, cosine of an angle is a ratio. Well, where does cosine equal 0? At this point up here, we're at 0, 1. And at this point down here, we're at 0, -1 on the unit circle. This angle is pi over 2, and this angle is 3 pi over 2. So I'm also going to say x is equal to pi over 2, and x is equal to 3 pi over 2. And I've got my 3 solutions. Wait a second. I've got to plug them into my original equation. Remember, this is the original equation. Let's see which are true, and hopefully they're all true. X equals pi. Cosine pi is -1 plus 1 is equal to sine pi. Well, sine pi over here is 0. So we have -1 plus 1 equals 0. That's a true statement. So we're good to go with that first solution. How about pi over 2? Cosine pi over 2, we know that's 0 plus 1 equals sine of pi over 2 is 1. So that makes a true statement as well. I'm saying 0 plus 1 equals 1. How about 3 pi over 2? Well, of course, the x at 3 pi over 2 is 0. So I say 0 plus 1 equals Sine of 3 pi over 2 is negative 1. So essentially I get 1 equals negative 1. Wah, wah, wah. Sorry, that's not a solution. Now, look what happens if I take the original equation. See, that original equation was cosine x plus 1 equals sine x. If I take that equation and I subtract sine x from both sides, by the way, we had a restricted domain, right? From 0 to 2 pi. Include the 0, don't include the 2 pi. So if I make this cosine x minus sine x plus 1 equals 0, and I graph this, the graphical feature I'm looking for is the x-intercept. Why? Because usually we have a y here. Now I'm saying y is 0. When is y 0? On this line, the x-intercept. And if I go from 0 to 2 pi, it's going to look something like this. Right here and here, if I go to my graphing calculator, I'll see that the solutions are, in fact, pi over 2 and pi, because I set my window to end at 2 pi and to start at 0. So graphically, I can get that same solution. Take a look here at what your book shows here, right there. There's a beautiful picture of it at the bottom there, next to this dude who's holding it up. That's the same picture I just tried to recreate here. And so you could solve this graphically as well. Of course you could.